Hi! In this video, we're going to solve problems involving integration by substitution. For our first example, we're going to solve for the integration of 3x times x squared plus 4 cubed dx. Integration by substitution is also called the integration by u-substitution. That means we are going to write our given problem in the form the integration of f of u du. Normally, in this kind of example, we are going to compare the exponents of x and we will assign the one with the higher exponent as our u. In this case, this x squared here. So we're going to assign as our u this x squared plus 4. So we have our u x squared plus 4. Then we take its derivative with respect to x. That will be 2x dx. And we are going to get the equivalent of dx by dividing both sides by 2x. So dx now can be written as du over 2x. So let us now rewrite our problem. This is our u and this dx is du over 2x. Then we will have 3x times u cubed and dx is du over 2x. And then as we can see, we can cancel the x here. And then we factor out the 3 halves. And we are left with the integral u cubed du. Then we just apply our rules in integration. We have 3 halves. And here it's 2 and then 3 plus 1, that's 4 over 4 plus c. Simplifying, we have 3u raised to 4 over 8 plus c. And of course, it does not end here. We need to replace u with x squared plus 4 to get our final answer. So it will be 3 times x squared plus 4 raised to 4 over 8 plus c. Let's now proceed to our next example. We have the integration of 10 cosine 5x dx. In this example, we are going to consider 5x as our u. And then we get the derivative of 5x with respect to x. It will be 5 dx. And the equivalent of dx when we divide both sides by 5 is dx equals du over 5. Then we will rewrite our problem 5x being u and dx as du over 5. We can cancel 10 and 5, leaving us with 2. And then we can factor that out. So we have 2 integration of cosine u du. Applying the rule for integrating cosine, we get 2 sine u plus c. And again, we have to replace our u with 5x to get our final answer. So we have 2 sine 5x plus c. For our next example, let's have 2x raised to 4 e raised to x raised to 5 dx. Again, comparing the exponents of x's, we take the one with the higher exponent as our u. In this case, it's x raised to 5. So u is x raised to 5. Its derivative with respect to x is 5x raised to 4 dx. And getting the equivalent of dx, we divide both sides by 5x raised to 4. So dx can be replaced with du over 5x raised to 4. So now we rewrite our problem, replacing x raised to 5 with u and replacing dx with du over 5x raised to 4. As we can see, we can cancel x raised to 4, and then the constant 2/5 can be moved in front of the integration symbol, and we will have the integral e raised to u du. Applying our rule for integrating exponential, we have e raised to u plus c. And again, we replace this u with x raised to 5 to get our final answer. So this is equal to 2/5 e raised to x raised to 5 plus c. For our next example, let's solve for the integration of 10x times square root of 10 minus 3x squared dx. So we are going to choose as our u 10 minus 3x squared. And its derivative with respect to x is negative 6x dx. To get dx, divide both sides by negative 6x. And we have dx as du over negative 6x. Now we rewrite our problem, replacing this with u and replacing dx with du over negative 6x. So we have 10x square root of u, then du over negative 6x. As we can see, we can cancel the x here and bring the constant in front of the integral symbol. So negative 10/6, we can get its lowest term. That will be negative 5/3. Then we have square root of u du. Or we can have negative 5/3 integral u raised to 1/2 du. Then applying our rule for integrating u raised to 1/2, we just add 1 to the exponent and the new exponent becomes the denominator. So that's negative 5/3. So u raised to 1/2 plus 1 over 1/2 plus 1 plus c, or negative 5/3 times u raised to 3/2 over 3/2 plus c, or that's negative 10 over 9 u raised to 3/2 plus c. And now we can replace our u with 10 minus 3x squared. So it's negative 10 over 9, 10 minus 3x squared raised to 3/2 plus c. For our next example, let us take the integral x squared over 3 plus x cubed dx. So for this example, let us take u as 3 plus x cubed. So the derivative of u with respect to x is 3x squared dx. And to get dx, we divide both sides by 3x squared. Then dx is equal to du over 3x squared. So there we write our problem. This is our u, and this is du over 3x squared. Then we can cancel the x squared and move the constant in front of the integration symbol. So we have 1/3. That's 1 over u cubed du. Then we can rewrite this as 1/3 integral u raised to negative 3 du. And applying the rule, this is 1/3. So negative 3 plus 1, that's negative 2. So over negative 2 plus c. So it will be negative 1 over 6u squared plus c, and again, replace u with 3 plus x cubed. So it's negative 1 over 6 times 3 plus x cubed squared plus c.